Hello everyone. Um, Today we are discussing largest rectangle in histogram problem. So in this particular problem, we have some buildings with some height. So this building has two height. This building has one height, 5, 6, 2, 3. But everyone has the same width, which is 1, right? And our task is to find out the rectangle with largest area, right? And now I have to give the definition. What is rectangle here? So if this is the size of the building 5, we will find out the building which has a smaller and stop there. So 2 is smaller in the right of 5. So we will stop there, and till this point we will go. And the left also we will do the same. Find the smaller. 1 is small, so we will stop here only. And this is the rectangle, right? So this is a rectangle we created with height 5. So the area of this is 5 into 2 because every width is 1. So 1, 1, 2, right? Now, if we want to create for the height for this particular thing, right, 2, what we can do, because in the right side of 2, there is 1 which is smaller, so we cannot go in the right. In the left side, nothing is there. So this is only the rectangle with height 2 here. And if we will assume this height 2, so we can go in the right because 3 is bigger. We can go in the left also till 5, and this will be the this bigger one will be the rectangle, and area will be 2 cross 4, 8. And these are the areas, and we have to find out the maximum one. So this is the maximum in this particular example. Okay, and we have to find out. So there are some approaches. So first approach, easy one, is order of n square. Okay, that will not pass the solution. So I will discuss the another approach, which is stack one, and which is order of n. It is optimized one. It is little tricky, so I will try my best to explain. So for example, what you are doing here during the creation of any rectangle, what you are doing, like this is the building 5, and what's the task? So I want to change this problem to some other problem. What I'm doing, I'm finding the building which is just smaller than this 5 in the right side, and same for the left side. So which is just smaller than 5 is, if you will go one step here, 6 is bigger. One more step, 2, oh, it's smaller. We will stop here in the right. In the left also, we are doing the same task. Which is smaller than 5? 1. Oh, next one is only smaller than 5. Okay, stop here only. So stopping here. So this is a rectangle. So what is the problem now? For every building, we are finding the just minimum on the right, just minimum on the left, and stopping there, and that will create our rectangle. For every building, we have to do this. So if I will tell you at every index, so I am indexing this 1, 2, 3, 4, 5. Okay. So for every index, I will tell, okay, this is the particular index which is just smaller. For example, 2, just smaller is 1. So we will stop here on. For 2, just smaller in the right is 4. So if I will tell you that in the left side, 1 is just smaller, and then the right side, 4 is the just smaller, you can easily tell me the area of the rectangle, right? How? 5 is the current building's height, and in the right, just more this 4, minus in the left, -1, and -1 we have to subtract, like you can clearly see that why. Okay, so minus we will also subtract, and this will give us the height 10, right? So with this particular solution, if I will give you this thing, for left, what is the index? 1. For the right, what is the index? 4. And now task is to find in the left and in the right. So for this approach, I will use the stack. So what I will do, just see, I'm creating one stack, and these are our heights, and these are our heights, and their indexes are 0, 1, 2, 3, 4, 5. And for sake, I am, because there is nothing in the left of 2, so I'm saying -1, and nothing in the right of, so it's fine. Okay, I will say 6. Okay, just to create extras, because we have to tell something. What is left of 2? I will say -1. What is the right of 3? I will say 6 index, right? Nothing is there, don't worry about it, but we have to add it. You will understand it why. So for example, we are starting from 2. So we are saying that stack is empty. If the stack is empty, we have to return -1, right? For the left case. Currently, we are finding the left part. what is smaller in the left part of every index. So I am generating left. For every index, I will tell what is the index of left building, which is just smaller, and right I will calculate after this. So I'm filling left. So 2, nothing is, stack is empty. So I will say just small in the left is -1, empty. And after that, what I will do, I will insert 2, right? And for 1, what I will do, I will see that 2 is already there, right? So 2 is greater than 1 is greater, 2 is greater than 1, right? We are finding currently for this one. 2 is greater than 1. So we will pop this out. Okay. We will pop this out. And now stack is empty again. Okay. Nothing is smaller in the left side. So we will again say that -1. No element is smaller than 1. And insert 1 in index. Okay. We will insert 1 in this particular array here. So now 1 will be here. Now 5 will be insert. And for 5, we are checking that, yeah, 1 is smaller. Okay. In a stack. So we will insert 5. And whatever the index of 1, we will store here in the left, right? So what's the index of 1? 1. So we will say for 5, 1th index value, which is 1, is less than 5 in the left. And now 6 will come. For 6, just smaller is 5. Just check the top one. Yes. Insert 6, and whatever the index of 5, just store here 2. And for 2, 6 is greater than 2. We have to pop this out. 5 is greater than 2. Pop this out. Oh, 1. 1 is smaller than 2. So whatever the index of 1, we will store here. So index of 1 is 1. Store here. So what is less than 2 in the left side? There's 1 index value, right? Do this for 3 also. This is popped out. So after this, we will push 2. And for 3, peak is whatever the stack's peak, which is 2. So top value is 2, and which is smaller than 3. Okay, we can store the index of 2 here because that is smaller, and insert this. So this thing is filled, right? Left part is filled. And do the same thing for the right part. Cool. You have to just do the same thing for the right part, whatever I did for the left part. Okay. And after that, you have left part and right part filled. So I will do the same. So I will follow the same logic for the right part also. Okay. So for the right part, I will insert 3. Okay. Nothing was smaller than in the right. So I will say 6 index. And now I will insert 2. I will check 3 is bigger than 2. Oh, 3 is bigger than 2. I have to pop this out. Now stack is empty. Nothing is bigger. Store 6 again. Now you have to push 2, right? So this is gone. Now in the stack, 2 is the top. Now 6 you are pushing, and 2 is smaller. Push it, and 2 is smaller than 6. Okay. Whatever the index of 2, you will store here, which is 4. Now you will push 5. Oh, 6 is bigger than 5. You have to pop this out. So pop this out. Okay. Now, oh, 2 is smaller. Oh, fine. So whatever the index of 2, you will store in the 4. And push 5. Now for 1. 1, oh, this bigger. Pop this out. Oh, 2 is also bigger. Pop this out. And now nothing is there. So you have to store 6 here. And push 1. And for 2, oh, 1 is smaller than 2. Okay. So whatever the index of 1 is here, store here. So both are filled. And after that, what you have to use, just a simple formula. Right. Whatever the height of the current I and its right value means this value, right I, height I, right I minus left I, and 1 minus 1 extra, which I explained why, right? So this thing you will calculate and check the maximum value of this. So this is the simplest manner which I can use to explain, but I use some extra space here, right? Because this is a simple explanation. If you want to save the space, you can save the space also, right? But yeah, this is the simple explanation. If you will save the space, it will become little complicated, but not much complicated. Logic is similar. Okay, so thank you for watching the video, and I hope it is well explained. If there is any doubt, please ask in the comment section. I will definitely try to help.